Yes, that is an explosion. And no, this is not an action movie. This is what happens when curiosity, plastic, and pressure meet, and nobody says, maybe we should stop. Welcome. This video exists for a very noble reason. We are comparing 3D printed materials for a Formlabs competition. Calmly, scientifically, and with pressure. We tested two 3D printed plastic spheres with identical geometry. One transparent, one gray. Each sphere is connected to a CO2 bottle with a pressure gauge monitoring internal pressure and a strain gauge measuring deformation as pressure increases. The valve is opened remotely using a rope because experience. In the first experiment, the transparent sphere is pressurized. The pressure rises steadily and the strain curve shows a clear increase as internal pressure builds. At around 8 bar, the sphere fails. The data shows significant deformation before failure, and the sphere breaks into a small number of large fragments. Educational, data-driven, and very final. In the second experiment, the gray sphere is tested. Pressure rises higher this time, reaching around 10 bar. The strain curve increases more slowly, indicating a stiffer response, but higher stored energy. When failure occurs, the sphere shatters into many small fragments, and the connector at the pressure gauge also fails and exits the setup at speed. This was not part of the experiment, but it volunteered anyway. When we compare the data, the difference becomes clear. The gray material withstands higher pressure, while the transparent material shows greater deformation before failure. Strength versus ductility, visualized very clearly. So what did we learn? The gray material can handle higher pressure. The transparent material absorbs more deformation, and failure behavior matters just as much as strength. Thank you for watching.